Have you ever pondered the mysteries of time itself? Does the future, a realm unseen and unknown, already exist somewhere out there? Time, an intangible concept that governs our lives, a ceaseless current carrying us from the cradle of the past towards the abyss of the future. But what if time isn't as linear as we perceive it to be? What if our future, in all its mystery and intrigue, is already out there waiting for us to catch up? Let's step into the world of determinism for a moment. It's a philosophical concept suggesting that all events, including our actions and choices, are ultimately determined by previously existing causes. If this is true, then does it imply that our future is already set in stone, a pre-written script we're merely enacting? Now let's venture into the realm of time travel theories. We've all heard of the butterfly effect, the idea that a small change in the past can set off a chain of events leading to a dramatically different future. But if our future is already determined, would such alterations even be possible? Or would the universe correct itself, maintaining a predetermined course? And then there's the space-time continuum, a concept that merges 3 dimensions of space with the 1 dimension of time into a 4-dimensional model. In this model, past, present, and future all exist simultaneously, suggesting that our future is not just a possibility, but a reality that's already out there. This interplay between determinism, time travel theories, and the space-time continuum creates a fascinating enigma. It challenges our understanding of time, pushing us to question whether our future is a blank canvas waiting to be painted or a masterpiece hidden in the shadows of the space-time continuum. In the realm of quantum mechanics and relativity, time is not as straightforward as it seems. So, buckle up as we delve deeper into this labyrinth of time in the upcoming scenes, exploring whether our future has indeed already happened. Imagine 2 particles of light, or photons, born at the same moment. These twin photons, born in the heart of a dying star, start their journey through the cosmos. One photon, let's call it alpha, heads straight towards a massive black hole lurking at the star's core. The other, we'll name it beta, makes a daring escape, shooting off in the opposite direction into the vast open universe. As alpha and beta journey through space, they experience the universe in contrasting ways. Alpha, drawn towards the black hole, is about to experience something extraordinary: time dilation, a fascinating consequence of Einstein's theory of relativity. As it gets closer to the black hole, the immense gravitational pull slows down time for alpha. To it, time seems to pass as normal, but for an outside observer, it appears to slow down, stretching each moment into an eternity. Meanwhile, beta, free from the black hole's gravitational clutches, continues its journey at the speed of light. It races across galaxies, witnessing the birth and death of stars, the collision of galaxies, and the ever-changing tapestry of the cosmos. For beta, time is a constant companion, ticking away at a steady pace. The tale of these 2 photons presents a remarkable illustration of the relativity of time. From beta's perspective, as it darts through the cosmos, it perceives alpha's time as having slowed down. The closer alpha gets to the black hole, the slower it seems to move, until it appears to freeze, trapped on the event horizon. But for alpha, it feels like it's plunging into the black hole at a regular pace. This divergence in their experiences brings us to a mind-bending conclusion. From beta's perspective, alpha's future has already happened. It sees alpha frozen in time, forever on the brink of falling into the black hole. But from alpha's viewpoint, it's still falling, its future yet to be determined. From the perspective of the photon that escaped, the future of its twin, trapped by the black hole, has already happened. This tale of 2 photons offers a glimpse into the intriguing world where the future can be both a present reality and a mystery yet to unfold. So, does this mean that our future is already written in the stars? Let's delve into this by deciphering the photon story we discussed in the previous scene. Our story of 2 photons can be explained by a concept in physics known as time dilation. It's a difference in the observed time measured by 2 observers due to a relative velocity between them, or to a difference in gravitational potential between their locations. When the photons traveled at light speed, time for them stood still, creating an illusion of the future already happening. But here's the catch. This is only from the photon's perspective. For us, time continues to tick away at its usual pace. Now let's add another layer to this puzzle, the uncertainty principle. In quantum mechanics, this principle states that the position and the velocity of an object cannot both be measured exactly at the same time. This principle introduces an element of randomness and unpredictability. Even if we know everything about the universe at this moment, we cannot predict the future with absolute certainty because of the inherent randomness in quantum mechanics. So where does this leave us? On one hand, we have time dilation suggesting the future might already exist from a certain perspective. On the other hand, the uncertainty principle throws a wrench into the works, asserting that the future is uncertain and unpredictable. It's like standing at the junction of predestination and free will. This paradox lies at the heart of our understanding of time and the universe. It's a question that has puzzled scientists and philosophers alike for centuries. Is the future set in stone, or is it an open book? Quantum mechanics suggests it's the latter, introducing a degree of randomness and uncertainty into the equation. While the future might seem to have already happened from a certain perspective, it's still largely a realm of endless possibilities. So, as we stand on the brink of tomorrow, gazing into the unknown, we can be certain of one thing. The future, much like the universe itself, remains a mystery waiting to be unraveled. But isn't the future predictable to some extent, you might ask? Well, let's dive into that. Many philosophers and scientists, including the likes of Isaac Newton, have subscribed to a deterministic view of the universe. According to this perspective, if we knew the precise state of the universe at this moment, we could calculate its future state. It's a bit like a cosmic game of billiards. If you know the positions, speeds, and directions of all the balls, and you understand the rules of the game, you can predict the outcome. This deterministic view paints a picture of a universe marching in lockstep to the drumbeat of cause and effect, where the future is just the inevitable result of the present. Time, in this view, is like a river flowing steadily from the past through the present and into the future. However, with the advent of quantum mechanics in the early 20th century, this view was turned on its head. Quantum mechanics introduced a degree of unpredictability and randomness into our understanding of the universe. It tells us that at the tiniest scales, things are not so cut and dry. Particles can be in multiple places at once, or spin in two directions simultaneously. They behave more like a cloud of probabilities than like billiard balls. This quantum view of the universe is inherently probabilistic, not deterministic. You can't predict exactly what will happen, only the probabilities of different outcomes. It's a bit like rolling a dice. You know the possible outcomes, but you can't predict the exact result of each roll. So, where does this leave us? We have a deterministic view of the universe on one hand, and a probabilistic quantum view on the other. It seems that the universe is not entirely predictable, nor entirely unpredictable. It's a bit of both. It appears that the future is a blend of predictability and unpredictability, a dance between determinism and randomness. So, has the future already happened? As we journey through the winding pathways of scientific discovery and philosophical debate, we find ourselves grappling with this riveting question. It's not just a question about time and space, but about the very nature of reality itself. What we've explored today is a testament to the astounding complexity of the universe. We've delved into the Enigma of Time, a concept so familiar, yet so elusive. We've pondered the tale of two photons and the paradoxical implications of their intertwined existences. We've questioned the predictability of the future and whether it's already set in stone, or whether it's a blank canvas just waiting for the brushstrokes of the present. It's easy to assume the future is a simple extension of the present, a linear progression that we can predict with enough knowledge and understanding. But as we've seen, this assumption may be far from the truth. The future, like time itself, is a complex tapestry woven from the threads of countless possibilities. It's not just ahead of us, it may be all around us, a part of the very fabric of reality. The future could be a vast ocean of potential outcomes, with the present merely the shoreline where we dip our toes. And yet, despite our best efforts, We're still only scratching the surface of these profound questions. The workings of the universe continue to confound us, to push the boundaries of our understanding. But that's the beauty of science. The more we know, the more we realize how much there is to discover. So, has the future already happened? The answer remains elusive, and perhaps that's as it should be. After all, if we knew everything about the future, wouldn't that rob the present of its mystery and allure? Perhaps the future, like time itself, remains one of the greatest mysteries of the universe, a riddle waiting to be solved.